Chief Architect of PhonePe, Shantanu Sinha, to take you right inside Drove. All yours.
My yeah, clicker. On a typical day, PhonePe get about 160 million users who do transactions about 400 million plus, and we end up getting almost a million requests per second. We keep optimizing it down, right? And so how all of this works basically is we would need something like a layer which executes the code which runs all of the transactions and all of the services, etc., that power the full experience on PhonePe for our customers and merchants, right? So typical architecture for that would mean you have some kind of a ingress layer which brings the traffic into your data centers or cloud or wherever you are hosted. And then you have a layer which actually executes the code which handles all of that traffic, right? So for that, you would have typically now everyone would be using a container execution layer. So you have some layer which handles the traffic, right? And what else is needed? You need some databases, etc. Mostly for us, we would the volume is so high, we always need to run these on sort of bare metal. So we would be hosting them off container and on VMs and BMs. And you need a way for the containers to talk to each other. And you need some management software and configuration management to deploy your containers, and hopefully some UI where you can see where things are going, right? So when we started PhonePe, basically what we decided to use was Apache Mesos and Marathon. So Apache Mesos was a project which came out of academics, and it was heavily used in Twitter, etc. A lot of companies, and you typically need something called as a framework which runs on top, which handles the life cycle of what is executing on the cluster, right? And traffic, I think a lot of people here would already know traffic is basically sort of like a load balancer proxy type thing which sits in front of computing clusters. And we had Nginx, which was our edge layer, right? So, about 4 or 5 years into the journey, there were some cracks showing up in the system, though we knew how to sort of manage Mesos and Marathon. But we work in a heavily, in a very compliance heavy domain, right? And we wanted something which would be a little bit more secured, etc. So we were thinking how to modify Marathon, etc., to handle our compliance related use cases. And we also face some weird issues on Mesos and Marathon. Fundamentally, uh, caused fundamentally by some of the design decisions, etc., they had taken. While we were discussing all of this, uh, on April 2021, Apache decided to move Mesos to the attic, right? So, which brings us to our talk, which is about Drove and how we basically built our own container orchestrator. And what we are going to do here in this talk is to basically figure out what are the parts of the system and how they are threaded together, and some of the design decisions sort of that went into building this system. So what did we want? Basically what we wanted was really simple. We just wanted some place where we could deploy containers which would be stateless, and that's about it. We needed operations on the containers, restart, deploy new versions, and that's it. Okay, nothing more, nothing less. And some obvious stuff, because we work at decent scales, we want the system to be like really simple, easily debuggable, fast recovery, and not without many single points of failure, right? And we are in the payments business. For those of you who don't know, like the margins are like really, really thin. Okay, so that means you extract as much from what you have. You don't have the luxury of throwing around a lot of hardware and uh, you know cloud infrastructure and stuff like that, right? So, and over the 5 years, we had also learned the common failure patterns. So, if we could handle some of them, it would be really good, right? So, and what actually worked out for us, and what we did not actually want to touch and or change. So, we are not on the cloud. Okay, we are on running off our own colos with our own servers. We do have a cloud presence, but that is like a very small part of the equation. Our databases handle so much scale that we don't want to put it on any containers, etc. They'll typically run on, they don't even run on VMs. Okay, most of them run on VMs, and yeah, that's like a whole big topic in itself. I'm actually looking forward to the next talk on, I think, the same subject. The other thing is we have a working service discovery. Okay, which is powered by, there is a blog post around this, which is powered by a library which I had written when I was working in Flipkart. We had working deployments. It might sound like a small thing, but our deployments are heavily audited by compliance. Okay, so changing that process, etc., itself is a big deal, and there frankly was no need to. It was something which was working. Similarly, configuration management. We have our own big observability stack with anomaly detection and auto corrections and stuff like that. So none of this we actually wanted to touch and or solve for, right? So what is drove, like what are the different parts, right? So basically we have the main cluster, obviously, right? We'll see what are the parts of the cluster, and we have a gateway which brings in traffic to the cluster. We have a CLI to interact with it, and we have a dashboard which is kind of part of the cluster itself, and we have like the DNS system which we can do some stuff with, right? So yeah, so like not many moving pieces, like these are the pieces we have. So what is the cluster? So cluster typically there you need one metadata store to store the cluster metadata, and for some coordination. Zookeeper, old fashioned, battle tested everywhere, really big companies, works really well, actively developed. It does solve for what it needs to solve for, and whatever we wanted it solves for, right? And then basically we have the controller, which is the brains of the system. It does a few things. Actually, it does all of the things. It does the resource allocation. It manages the cluster topology, as in what is where, like where the what resources are there, what is up, what is down. It will also do the outage management, right? And it gives out information, and yeah, that's kind of, as you can understand, it's mostly like the brain of the system, right? And then you have the actual executor. So executors are where the containers run, right? And what happens is basically the controller sends commands to the executor to spin up a container. It will do the lifecycle management, etc., of the container, and it keeps providing updates of what is used, what is unused, and so on and so forth, right? So we have mostly covered this part. I just wanted to do a small thing, which basically we use both Docker and Podman. Podman because we have certain installations on Red Hat Enterprise, so they use Podman. So our system works well with Podman, right? So what can we deploy? We can basically deploy applications. Applications are basically services. You have, they can expose ports, and they're long running processes. We have tasks, which are small containers which you spin up. Let's say, for example, you want to do some kind of reconciliation. Between A and B, you spin up a container, it will run the DB query, do recon across 5 systems, and die. It doesn't expose a port. Then we also have something called as local service, but this is more for operationalizing use cases. Local service is something which will spin up on all of your executors. Let's say, for example, you have a metric collector. Okay. So that you need on every single machine, right? So it will spin up, or a log tailor and stuff like that. So this is mainly for operationalizing stuff inside Drove. Okay, so one of the things we decided to do was try to extract as much performance from the hardware we had. So typically, a server nowadays will have multiple CPUs. So they are the NUMA nodes that you have, right? And in a lot of the systems, they typically tend to abstract away the architecture of the system. We decided to embrace it. Okay, and you get a lot of difference in performance. So let's say you have some kind of an ML model running which does a lot of in-memory operations. So these are the 4 cores, right? So let's say you have 2 nodes, 4 cores. So you have a container running here using memory here versus a container running here and using this memory, right? It would get a lot more performance. That is the other thing we wanted to do is stop containers from stepping on each other's toes. Okay. So we decided to bake it in like this, which is basically for the OS, we would reserve some cores. Okay. Drove doesn't do it. Drove doesn't need to do it. You can configure it in your systemd init script. You allocate 4 say CPUs. There is a simplified version, but one core from both to the OS, right? And a percentage of memory. You don't expose all of the memory as available. You say expose 80% of the memory. So those 4 cores are in this case 2 cores, and the 10% memory is what your operating system gets to use. Rest of the cores is basically exposed to Drove along with the NUMA topology of the executor. Okay, it's all exposed to the controller, right? And then basically when we allocate a container, it will take cores only from a single NUMA node, and memory will also get allocated from that NUMA node. So we are right now working on doing GPU allocation also like this. So that should be out in the open source version, I guess, in 1 or 2 months, right? And the way you can share is basic. Oh, but all the cores are CPU set. Okay, so when a core is allocated to a container, it is not shared with anybody else. First testing environments, etc., it becomes a little expensive. So what you do is you have we have something called as multipliers. So this 4 cores will be 3 cores will show up. You can make it show up as 30 or maybe 12. So what will happen is it will still be the same. It will still be one container, but the code will be shared by 4 containers in that case, whatever is your multiplier. So that way you also get to share. It's a very simple model. You can turn this off. We do turn it off in our environment. There also it is still NUMA, but everything will show up as one NUMA node, okay, in a virtual manner. I don't have exact number. Shubham has a talk later. Shubham can tell me the number, but off the top of my head, I remember one of our ML scoring models just saw a straight out 35x performance gain. Okay, just by moving to this model, right? Simple basics, nothing like there's nothing special going on here. Like the whole code of Drove is, I think, around 24,000 lines. With testing code, it would be, I think, with testing code, it's about 30,000 lines total. Okay. Uh, yeah. So container placement, you have some options. You can do it as any, which is what I typically recommend everyone to use. Just do any, it will go everywhere. You can do one per host, n per host. You can tag specific executors. Let's say if you have executors which have GPUs and you are deploying an LLM that you want to run on those machines only and nothing else to come in, you tag the executor as, say, for example, has GPU. And when during deployment, you say you place these containers only on machines that have GPU. Okay, so like that. We have a composite one. Uh, where you can basically do one per host plus tag based and so on and so forth. And this is the new one which I just merged, I think, couple of weeks back, which is rule based, where you can create complex rules in MWell, or there's another language which I had written, which I don't recommend anyone use, called Hope, but mostly MWell. Okay, there you can do a little bit of interesting stuff. Like, say, why this is needed is, let's say, as your company grows, right, you get machines of different types, right? So, for example, you got some old Skylake machines, you got some Ice Lake machines. Now you have spanking new AMD Threadrippers. So per core performance differs a little bit here and there, right? So if your service is taking a lot of traffic, our typical service would take like a million RPS, 500,000 RPS, 800,000 RPS. It's very common. So at that scale, it creates a difference. So with a rule, you can say, okay, if your Ice Lake is say 2x faster than your Skylake, you can say place 2x more containers on Ice Lake versus what you're putting on Skylake. And we've also added properties, etc., to executors, so all these details can be exposed. So this is what the dashboard looks like. Some information, number of cores, memory, how many are running. This is the coefficient of variance of allocation. So if this goes, there are some ranges. You can see how much the balance is in the cluster. You can rebalance a little bit if you want, right? It gives out so this is embedded in the controller only. You don't need to deploy anything else for this. So auth, there are three type of auth which is basically present. One is the user to controller. In the open source version, we only have the OSS username password. And for API calls, obviously, you'd need basic auth with that username password. And in our internal version, we also have support for auth using our own auth. We have our own auth service, so we have support for that. It is modular, it can be easily built, external support. Why, etc., we can discuss later. But yeah, so it has roles. You have read-only roles where by the way, that console is completely read-only. Okay, you can't make any changes from that. You can download logs, etc., from there. And yeah, so we have read-only, read-write, and maintenance, where you can change some cluster configuration, blacklist nodes, and so on. We have a different secret-based auth between controller and executor. You don't have to add an executor to the cluster. It was a conscious design decision. If it comes up and is able to ping successfully, it gets added to the cluster, especially for situations where you have executors which are also on autoscalers. Having not needing to have that extra step to add that to the cluster basically speeds things up everywhere. And then you have something called as a controller container auth, which is needed. So when a container starts up, Drove will inject a auth token into it. And you can use Drove's libraries to discover your peer. Like, it can make a call to the control specific APIs on the controller to discover your peers. So let's say if you have some kind of clustering software like Hazelcast or Ignite or something like that, where I don't know, there are a lot more now, right? So if you need to discover your peers, you can use that token to find your peers. Okay. So these are the three type of auth we support. So what is the next thing that we need to done? We basically need the containers to have some kind of configuration available to them. So we provide a total of 4 types of configuration. One is, so spec is how you define an application or a task or something, right? So you can embed the configuration directly into the spec, right? So that is the inline mode. The second one is you can place a configuration on the executor by whatever you have, like Salt or Ansible or whatever you're running, and you can load it into the container. Okay, you can give the path name, etc. Load it into the controller. The other one is you can provide endpoints uh, to the executor, and it will fetch the config directly from the executor and inject it into your control container as a config map or whatever it's called. Right? It's available as a file or directory or whatever. The fourth one is similar, but in this case, the controller will pull the config and distribute it to the executors. We have the two modes because of to give some flexibility across different firewall zones. Okay, in the last mode, your executors don't need direct connectivity to the config service, for example. Okay, so yeah, so this is how all the configuration gets injected into the containers. Uh, Next, you need to see what is going on. So all the metrics for the cluster are available over HTTP from the controller, and individual container, etc. metrics are available again on HTTP on the executor. We do not enforce any specific collector, etc. You can bring your own collector to collect the metrics. Okay. And now with local services, it is much more easier. Basically, you can just deploy a service which will fetch all the config. Besides this, we also emit a lot of events, and there are APIs which you can subscribe to basically poll and find all the new events. There are no push APIs, there is no WebSocket, there is nothing like that. Okay. The code is as simple as possible because I have to maintain it along with 200 other things I have to do. Okay. So yeah. So yeah, so you have events and plus special audit logs which basically come into your this thing for all human tasks. If you're logging in as a human being, your actions will get logged in the audit log. Okay. So the last complex part is basically communication. So how do the containers communicate with each other, and how do different applications and the services communicate with each other, right? So yeah, so we have two things for this. One is the gateway, the other is the Drove DNS. So gateway is basically nothing. Okay, it is a Go program which makes a call to the controller, gets the details and updates. You can choose either a HA proxy configuration or a Nginx configuration. The last thing we wanted to build is basically a proxy, like while Nginx and HA proxy exists, nobody should be writing a proxy, in my opinion. Okay. So we didn't go, it is just a polling service. Okay. Polls and updates your config, makes API calls if you are using Nginx Plus so that your service restart, etc. is not needed. Drove DNS is again, we did not want to do DNS. Nobody wants to do DNS. So we just wrote a core DNS plugin. Okay. So if you have core DNS infrastructure, you just add this. It will get all the containers, right? So with the empowered with this, how do we work? So let's say we have two containers of one service and one container of the other service. So the first instance wants to call the this thing typical way. This would know the vhost, so it would make a DNS query for the vhost. The DNS server would give the gateway's IP, and it would make a HTTP call, right, which will get routed through the gateway into the container, right? But this will work obviously well, like it's an established pattern. There's nothing special. The problem with this is your gateway becomes hot, right? It is like a single point of failure. You can keep adding machines to it. It won't be issue, but till the point of time it actually becomes an issue, right? And there is another way actually, and DNS provides us something called as SRV queries. And with an SRV query, you can basically get both a host and a port. Okay. So when the other way to call is, instead of making a vhost normal A query, it is going to make a vhost SRV query. And when it does a vhost SRV query, the Drove DNS will return A2A1's direct host and port. Okay. And then A1 and A2 can talk directly. The gateway is completely out of the picture. Okay. So this basically gives you a much more robust way of talking. I need to give this disclaimer that we were already using Ranger for our complete service discovery. We have done a lot of work on Ranger there to have different backends, including Drove, which I haven't included here. So we are not directly using the SRV one as of now, but yeah, we have tested it well. It works perfectly fine. In case you are planning to experiment with it, feel free to do it. It is properly tested. Right. Yeah, so we have covered all of this. And the last piece of the puzzle is the CLI. It gives you everything. It basically gives you read, write, ability to tail logs, tail events, uh, and call maintenance, and so on and so forth. And it also provides a skill which you can use with your coding agents. Right, so where we are with this now. So with this simple architecture, we can basically upgrade a 300 400 node Drove cluster in about 2 minutes. Okay, your every single one of your components in the cluster can go down if you are not using like a like even in the Drove gateway, the polar goes down because it is Nginx. Everything continues running. All the containers are up and running. You can react. You get some time to react and fix things and so on and so forth. Right. So everything is running, and there is a maintenance mode where you can basically bring down components and bring down the controller, do maintenance on the controller. There is blacklisting mode where you can take out executor, where it will migrate all the containers out of this. We have also tried to do a decent amount of documentation. So I thought I'll just basically give a quick demo of the thing. So I don't know if it's playing. Yeah, it's playing now. So yeah, so this is basically what this is the instances page. This is what a spec look like. Right, and these are the local services. We have something which is inactive, a similar looking spec. And this is the cluster. It will show you all the executor. You can see the node and all the NUMA cores in that. Right, so we install the skill. I use open code. So yeah, so basically we can now use open code as an interface to interact with the cluster. Okay. This video is not edited. Any slowness you see is not on Drove or me. It is because the model is slow. Okay. So the skill enforces that it install or find, and if not, it will install. So it does a ping, finds everything. Things are there. It sees it's in monitoring state, right? So right. So we are going to scale up. The scale up you can do in parallel also. All of these things are configurable, how much parallel you can go and stuff like that. So containers are up, right? You can see it became from scaling to running. So this guy has come back saying, okay, it is running now. So we are going to deploy a task now, right? There are some sample tasks available on the Drove repo. So I'm using that to create a task. In the sample task, there is something called as iteration. So it will just bring hello, 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 hello if once every second. So I just told it to start something with 30 iterations. So it is going to do that. This is slow model, okay, not slow draw. Yeah, so it has started provisioning. So everything has its own life cycle, okay. All containers have their own life cycle. So this is the log. You can see all the logs from the console. You can use the CLI to tail as well. You can see it is printing all the iterations. This is the console. You can download the log from there. So local services have their own life cycle called activate and deactivate. So you can do a configuration test first, spin up one local service on one machine. If it works, you say activate, and the system will automatically spin up all the services from spin it up on all boxes, right? Any containers go down, controller is always monitoring, it will spin up on a different box. Any executor goes down, equivalent stuff, it will always try to bring the system back to equilibrium. Okay, so all that the controller will do, right? Yeah. So uh, at PhonePe, we are everything runs on this now, all containers. Okay, every single one of your transactions um, is going through this. So we have 300,000 cores, about 2 petabytes of memory, 50,000. It's actually around 60,000 containers, 3,700 plus executors, 75 clusters. It is deployed on all kinds of architectures. Machines having GPU, without having GPU, Intel, AMD, ARM, macOS, Ubuntu, RHEL, etc. We deploy all of our models, like whatever is running. We are currently running Kimi, Quen, a bunch of Quen VL and so on. Everything is running on GPU machines on this. All of our computations, Debezium pipelines, data warehousing jobs, everything runs on this. One of the cool things that we also have is we can spin up Android emulators on Drove. Okay. So a lot of our testing, QA testing on app actually happens on this. So this has Drove has support for device mounting. So you mount your KVM, dev KVM into container, and you can spin up emulators on this, right? So yeah, so I guess that's about it. There are some stuff which we are looking at, which is we are doing the NUMA aware GPU resource management. You can slice your GPUs and allocate smaller models and so on. We are thinking of stateful containers, but primarily for testing environments. The scheduling is currently built in. With increasing complexity, we are thinking of exposing an external interface so you can deploy maybe an LLM powered algorithm or something to optimize the placement of containers based on external factors. And there is a branch I have without ZK, but mostly I'm gonna kill it. Okay, it's been working fine for us right now. Yeah, questions? Yes, yes.
It's running everything that you just showed.
Can you,
It's running everything that you just showed
yes,
for PhonePe.
yes,
Before you actually, when Apache said no more of that old solution,
yeah.
how easy was it for management to say that yes, this is going to be running the work, this is going to be our workhorse? Right now, it's obviously battle tested. What did that look like?
We don't generally work with safety nets. Okay. I
And
think that's the only way to get things done. Like you don't have a safety net. And there is a whole big safety net if we need it big and complex, but it is still there, which is Kubernetes, right? You could always take a look at that if this thing didn't work out.
and then how did it look in you are in a compliance space, regulated area.
Yeah, yeah.
How did that look like? No safety nets, but still being able to, work this whole thing out. It's a pretty big bet. How did that look like?
I mean, look like as in, can you rephrase your question?
Absolutely. Regulators generally want to see static solutions which don't change very often. They say,
Yes.
oh, this is well
So
tested.
there have been situations. So we run a lot of our own custom stuff. Okay, Drove is one of them. Shubham will talk about the other one. So we are used to basically running auditors through our code.
Okay.
So they'll sit with us and they're like very good generally at this kind of stuff. I get where you're coming from, but yeah, you have to spend more time. And we also have a really good compliance team, very technical, so they can handle field a lot of questions. And we happily sit with the auditors and run them through. And it's very small, okay? You can actually go through the whole code in, I guess, one evening. So it's not that difficult.
Fantastic. Thank you. I'd love to learn more about the compliance bit whenever you have an opportunity.
Yeah. We actually have a Discord. If you go to the site,
Okay.
there's a Discord. You can go join that and ask questions.
All right. Perfect.
Be happy to
Thank you.
Yeah.
Shantanu, something very obvious. Why not Kubernetes? Battle tested container.
It wasn't so battle tested that time.
It has.
And it is really complex. Okay, it solves a lot of problems which we did not have. At some point of time, you need to maybe take a pause and think, okay, do we need this big thing which can do a lot of stuff, has 800,000 lines of code? Do we actually need all of this? Or basically, we can apply some first principles and we know what works. See, 5 year, like when 2021, we were not so small. Okay. So we know what works, what doesn't work, how our see this kind of things. The problem is you are not only changing a tech stack. Okay, please sit. We are not only changing a tech stack. You are changing a lot of things. You are changing a process. Okay, you are changing your compliance, and there's cost associated to every one of them, right? And here I can sit with a couple of people from SRE team, build it out, right? Get test, deploy, and slowly take it live. It works for us, rather than people having to learn like a huge stack with its own nuances, which people wrote maybe to solve their problem. At some point of time, I think we should be okay to take a step back, look at the forest, and roll up our sleeves and write some code.
So once you move to stateful containers, you would still need something like an operator, which they have like.
Actually, the thing is, one of the things PhonePe does is basically we invest a lot in open source. So I don't know how many people know here. There is a distributed file system called GlusterFS. So the global project lead and a part of their plane, etc., they work for us. So what we want to do, I am not excited about the stateful containers. I am more excited about what we are trying to do is bring block storage on top of GlusterFS. This is just a small use case. I can deploy a local service container which basically provides the binding, right, to the engine running there. But what I am hoping will come out of that project is stateful like block storage on top of GlusterFS. Okay, so yeah, we'll manage. It's again like not a lot of code. Most of the work we are trying to do in GlusterFS domain, the work on Drove side is very less.
Got it. Thank you.
Yeah.
I think one there.
Hi, Shantanu.
Yes.
Thank you for the talk. You being very humble, but it's mind-boggling for us to just comprehend this one.
It's very simple, by the way.
Yeah.
There's nothing complicated.
No, like we use like cloud everywhere, so it feels pretty much like mind-boggling. So my question is around like not like on this one. Like I want to ask like on application service developer, like what are the abstraction you provide? Like I mean, people go and provision their cluster and deploy their services, or you have one cluster for all services in the PhonePe?
There's no cluster. They define an application, say, give the Docker container URL and how much CPU RAM, how many instances they need to start up. And some port, etc. information. That's it.
And then
There's no cluster definition, nothing like that. See, we don't need it
no,
because
okay.
one of the reasons why you need it is basically bounding of the resources.
Yeah.
But the way our schedulers work, they don't anyway share anything. Course, when your container comes up, it does its own course. I don't care what is running. Network could be an issue, but typically nowadays data centers network bandwidth it would be difficult for application level software to exhaust a machine's bandwidth.
On like that regards, I mean, in terms of let's say some isolations, like one is like noisy neighbor. Like how do you like manage such that like some services not asking like too much of resources in terms of like
What?
provision?
Too much of what resource?
As in like number of containers and cores they ask such that I mean
Don't care. Everything is isolated. Why do I care?
with the auto scaling as in like does like do you like provision upfront that for this service like is this the maximum limit or
We have again. This is something we did not build for Drove. We already had our own autoscaler, which looks at metrics and keeps scaling. So when you deploy your container, you deploy n number of containers at start. Then the autoscaler will take over and keep spinning up and down.
no my question is let's say as a service owner if I ask for like very big auto like I mean a window of like auto scaling right and many such services like start doing that so I mean will it not create like noisy neighbor problem where basically
Noisy neighbor is a problem if you are sharing resources. If you are in an apartment and you have a noisy neighbor, it's only a problem if you are sharing a wall. If you have 200 meters gap with that guy, why do you care? Let him rave all night.
but you are deploying like your own data centers so then like do you have like those many machines available or like you how do like actual hardware level at a
300,000 codes you saw, na? We have
all the time
Yeah.
okay and like
We do shut down some machines here and there, but I mean, we don't not get a lot of traffic throughout the day. Like our downtime is very less. Like
understand. Okay.
you understand? No, PhonePe everyone is using all the time. Like even late night, there will be some less traffic. Obviously, we have peak and trough in our traffic as well, but it's not low enough to, spin down bare metals completely. Right? We do spin down some containers because at night some tasks like daily recon and so on and so forth. The spare capacity is used up by those tasks during that time.
So then like you do the capacity planning across the PhonePe like
We do
Sorry,
across.
can we?
okay.
Sorry, you can catch him offline.
Okay.
Yeah, we
Comment
do.
on
We
his,
do it to finish off this. Yes, we do it across the company.
Okay, thanks.
Yeah. So just to extend, right, I had a question of my own. Just extending what Monish asked. Looking back, what's the tipping point when you, in general, decide to build something of your own versus something that exists out there? Is it more about the kind of business, PhonePe, where reliability is very important, or it's mostly about the tech stacks that are existing? They are bloated, they don't solve the problem for you. What's the day-to-day culture and decision-making process that?
Actually, I think it is neither of them. Okay. I think it is always what you do is always a function of what capabilities you have available, right? What is you should always play to your strengths. The thing is, for us, this sort of made sense. This was like a simple enough problem which we could pick up, manage, and have like whatever processes we had, which are fairly robust, not change them too much. At the same time, at this point of PhonePe, I say, for example, would not pick up writing a RDBMS. So yeah, we have whatever we have, and we have to pick our bets accordingly.
Great.
Right?
So I think Rahul talked about first principles, sticking to them as an IC, and I think Shantanu showed us how PhonePe is sticking to first principles on the core infrastructure layer that runs the most popular app on our phones. And it's incredibly inspiring that as a techie, he is setting up a culture. He himself is hands-on, like he said in his own words, roll up sleeves, write code, and make it available to the community. I think one thing that has remained constant, knowing him for the past decade, is don't shy away from writing the code.